examples involving the exponential function and the natural logarithmic function. And in example 3, we asked to solve for x, and we have log of x to the base e added to log of e to the base x equals to 2.5. Now this is an unusual question because if you notice, you have two different bases. One is base e and the other one is base x. And we can only manipulate or solve log problems if they are of the same base. So we need to use the change of base law and change one of the bases. And the base that I'm going to change will be the log e to the base x. I'm going to change that to base e. But before we start, let's revise the change of base rule. So if I had log of x to the base a, so I've got any log of x to the base a, I can change from base a to a suitable base, so it becomes log of x to the new base. Let's call the new base n. So this becomes log of x to the new base over log of a to the new base. Now with logs we have to be careful. There are certain restrictions. So when we're changing base or when we solving log problems, we must always make sure that the base is positive and the base is not equal to 1. So here a has to be greater than 0 and n also has to be greater than 0. A cannot equal to 1, nor can n equal to 1. And remember, we cannot find the log of a negative value, so x has to be greater than 0. Now let's look at log of e to the base x. Just consider that term. So if we got log of e to the base x, and if I want to change this to base e, then I'm going to have log of e to base e over log of x to base e. And log of e to base e has a value of 1 because we have the little rule that says log of a to the base a equals to 1. So this is 1 over log of x to the base e. So let's substitute that into our question. So our question now reads log of x to the base e plus 1 over log of x to the base e equals to 2, 5. I'm going to write it as the improper fraction 5 over 2. Now log of x to the base e is the natural log and it is ln of x, but I'm going to leave it as log of x to the base e. Our next step now is to simplify this expression, and we're going to find the lowest common denominator, and across we see that the lowest common denominator will be 2 log of x to the base e. So we multiply each term by the missing factor of the lowest common denominator, and we see that the first term becomes 2 log of x to the base e, or ln of x squared. My second term must be multiplied by 2, and I then have 5 log of x to the base e. And do you notice that you have 3 terms, a square term and a constant, and so this is a quadratic expression, so I'm going to write it in standard form. So we have 2 log of x to the base e squared minus 5 log of x to the base e plus 2 equals to 0. So we wrote it in standard form. We're now going to factorize this equation. To help me to factorize this equation, I'm going to use the method called k substitution. So I'm going to replace log of x to the base e with k. And if I substitute it into my equation, I've got 2k squared minus 5k plus 2 equals to 0. And this is factorized into 2k. The factors of 2k squared will be 2k and k. The factors of 2 will be 2 and 1. So I'm going to have minus 2 minus 1. And these are my factors. So I now know that k can equal to a half, or k will have a value of 2. But what is k? K is log of x to the base e. So log of x to the base e, or ln of x, equals to a half, or log of x to the base e equals to 2. So we need to solve for x. We're going to now change it from log form to exponential form, and the base of the log becomes the base of the exponent. So I got e to the half equals to x. Or I have here x equals to e squared. Now have a look at your values. So if x equals to e to the half, you know, exponent half implies square root. So that means x equals to the square root of e, and that will be a positive value. And e squared will be a positive value. So both the solutions hold, because if we go up to the beginning, where we noted our restrictions said that our solutions, or x has to be greater than 0, and both the solutions are valid. So this question has two solutions. One is x equals to the square root of e, the other one is x equals to e squared. So we're looking at example 4, and example 4 wants us to solve for x, and we have ln of x plus 1 minus ln of 1 minus x equals to 1. Now, before we start, let's look at our restrictions. We know we cannot find ln or log of a negative value, so I have x plus 1 must be greater than 0. So I have that x must be greater than negative 1. My second restriction will be that 1 minus x also has to be greater than 0. And if I simplify this, I see that 1 is greater than x, or x is less than 1. So my solutions will lie between 1 and negative 1. Now let's start. So looking at ln of x plus 1 minus ln of 1 minus x equals to 1, what we're going to do is, for us to solve for x, we need to write it in the exponential form. So I'm going to apply the rule where when I have log of a minus log of b, well, it's actually one of the laws. It says when you have log of a minus log of b, you write it as log of a over b. And remember that a must be greater than 0 here, and b is greater than 0 here. And this could be to any base. So let's just keep it to base n. So that means that the base must be positive and the base cannot equal to 1. So these are the restrictions that I need to consider. Now, applying that law, I can write ln of x plus 1 minus ln of 1 minus x as ln of x plus 1 over 1 minus. So the ln of this whole expression equals to 1. My next step is now going to change. I'm going to change it from log form to exponential form, reminding myself that ln is log of x to the base e. So I have x plus 1 over 1 minus x equals to e to the exponent 1, which is e. The lowest common denominator is 1 minus x, so I multiply both sides of the equation by 1 minus x, so I get x plus 1 equals to e times 1 minus x. Let's remove brackets here because we need to isolate the terms that contain the variable x, as the instruction is solve for x. So I have x plus 1 equals to e minus ex. I'm going to take all the terms that contain x to the left-hand side and all the constants to the right-hand side. So I have x plus ex equals to e minus 1. we take out x as the highest common factor. So I have 1 plus e equals to e minus 1. So x equals to e minus 1 divided by 1 plus. Now that you have the solution, the question to ask yourself, is it a valid solution? So we got x equals to e minus 1. Now e has a value of 2,7182,818, etc. So if I go, let's just substitute it. So we see that x equals to 2,7182,8, etc. minus 1 all over 1 plus 2,71828. So this gives you a value of 1,718 all over 3,718, which is positive. So this is a valid solution. Entering this value on the calculator, you see that we get 0,46211 as the result. Now, if I go back to my question, and if I substitute x equals to 0,46, let's just copy down the question and let's just check. So I see that x equals to 0,46. So if I substitute x equals to 0,46, then I have ln here of 1,46, which is positive. And there I have ln of 1 minus 0,46, which is also positive. And I'm just looking at the left-hand side of my equation. And so I can say that x equals to e minus 1 over 1 plus e is a valid solution. As in both cases here, I have ln of a positive value in both the terms.